Restart the record. Okay. So we are trying to do this numerical 2. So that numerical 2 is over here, 1.1 less than x less than 2.1. So fx 2.1 minus fx 1.1. 2.1 will be 1 minus exponential minus 2.1 squared by 4. And that is what we have here. In place of x, 2.1 squared. Again, in place of the same x over here, 1.1 squared is what is what you call written over here. So the value is evaluated and we are getting here minus 1.1025, and this is exponential is nothing but e to the power of minus 1.1025, and that turns out to be 0.332. Similarly, the exponential of this is e to the power of this, and that turns out to be 0.7389, and together that will just give us 0.4069. So that's the first numerical. The second numerical is, with fy equal to this. So this will become now fy1 less than y less than y2, and this will be fy y2 minus fy y1. So we need to substitute over here 6.2 and get fy y2, then substitute 2.5 in this and get fy y1 and subtract 1 from the other, right? So in the same way, we can try to do the other numericals also. So this is the what you call table over there, and we can try to find out that. Okay, so this is a different unit. Let us not go into this. This is problem number 7 in more detail, right? Before going to this, let us try to go back to our what you call if you see over here in the numericals over here, five, 6, 7. If you see this, random variable z is normalized Gaussian and its variance, mean is 0 and variance is 1. Find the probability. Again, similar thing. Again, same thing. So 5, 6, 7. 3 numericals are same. You can see this. 3 numericals are similar. Similarly, these 3 numericals are similar. So we need not solve all of them. In the class, we'll try to solve only one of them. Rest 2 you need to solve them, right? So we will try to see how one can do that. So 5th is over here. The random variable z is normalized Gaussian and its mean value is 0 and its variance is 1. Find the probability p of minus 0.505 less than z less than 1.56. 456. So fz 1.456 minus fz minus 5.05, and this is what we need to write it. And this I have explained to you in the last class how we can try to do that, right? We can try to do that. So in the same way, we can try to find for the numerical 6 also, where the p-value is from 1.003 less than z less than 2.392. So in the same way, the numerical is solved over here. So for this 2.392, we can go to the table and see how it will, what will it correspond to. Okay, so if we see over here, let me show you from this table, right? What was the value there? 2.392. We are talking about this problem, 2.392. 2.392. So 2.392 is 2.30. What you call 1, 2, so 9 will be here. 2.39 will be 0.9916. 2.39. 392 means it will be between 2.39 and 2.40, right? So this is 0.9916 and 2.40 is 0.9918. So somewhere between this. So you can almost say that it is almost equal to 0.9916, or might be, we can try to interpolate it and calculate it. So that interpolation is being done over here, 0.9916 plus this value 2.392 minus 2.39 divided by 2.4 minus 2.39 multiplied by 0.9918 minus 0.9916. So that will turn out to be, 0.99164. Okay, 0.99164. Similarly, for this, minus 1.003, minus will not be available. What will be available is 1.003, and minus will become 1 minus of that value. Okay, so 1.003, let us see from the table how much that will correspond to. 1.0, and this is 1.00, and this is 1.01. So 1.003 is between these two, 0.8413 and 0.8438. Okay, 0.8413 and 0.8438. So look at that point, let us not bother about this one over here. Let us see the rest of the thing, 0.8413 plus 1.003. This is the value which we want to find, minus 1 divided by 1.01 minus 1, because these are the two values which we are trying to find. And corresponding to these, we have these two, 0.8438 and 8413. Okay, from the table, 0.8438 and 8413 corresponding to 1.01 and 1.00. Okay, so those two values are written there, right? And we try to find out that, and that turns out to be 0.84205. And if you subtract from 1, that quantity, you'll get 0.15795, and try to subtract that, you'll get 0.8337. Similar to that, we have the numerical 7 also in the what you call question over here. Is this the same thing? Just let us see, minus 2.335 less than z less than 0.595. This is normalized Gaussian. Okay, normalized Gaussian is what we are trying to do. Let us see that number over here. Yes, minus 2.335 and 0.595. This is the p value. Same p value is there here, right? So this quantity is nothing but fz 0.595 minus fz minus 2.335. So you'll get 0.595, but you'll not get value of minus of this. So you need to take the positive value. So, exact method I have tried to solve in this to find fz 0.595 in the normalized Gaussian distribution table for 0.59. So 0.595 is between 0.59 and 0.60. Okay, between 0.59 and 0.60, it is the value. So corresponding to this, the value is 0.7224, and corresponding to 0.60, it is 0.7257. Let us see that in the table. Okay, 0.59. So this is 0.5. 0.59 is here. It is 7224. 0.6 is 0.7257. 7224, 7257. Okay, so those two values are written there. For 0.59, the value in the table is 0.7224. 0.60, the value is 0.7257. So how much is the value for 0.595? That's what we need to find out. And to find that, we have this interpolation at Z1, which is 0.59, we have 0.7224. At Z2, we have this value, 0.60. At 0.60, you have 0.7257. So at Z, it will be FZ Z1 plus Z minus Z1 by Z2 minus Z1 multiplied by FZ Z2 minus FZ Z1. So this quantity is 0.7224 and Z is 0.59. 0.595. This is what we need to find out. Minus Z1 is 0.59 divided by Z2 is 0.60. Then the value of Z1 is 0.59 and the FZZ2 is this quantity, which is 0.7257, and FZZ1 is this quantity, which is 0.7224. Okay, so you need to find that and you'll get this value to be 0.72405. 72405. So the value corresponding to this is nothing but FZ 0.595. In the same way, FZ for minus 2.335 can be found out, and that is 1 minus FZ 2.335, and that quantity will just give us, again, you need to do the interpolation. Same formula we try to use, whatever we have written here. This formula is with a lot of clarity. We have written this over here, where Z is where, at what position, FZ is what position, Z1, FZ, Z1, and Z1 here, Z2, FZ, Z2 here. Okay, so we are trying to find this. So we are trying to write again the same, interpolation, and FZ 2.335 is what we are trying to find out. So at 2.33, this is between 2.33 and 2.34. At 2.33 in the table, we'll get 9901. At 2.34, you can get the table, you can get the value 9904. And that again, we can check in the table. I'll go for the table here because that is convenient to me. So point, how much is that? 2.33 and 2.34. 2.33 is here. 2.301239 9901. 2.34 is 0.9904. So these two values which we are taking over here for 2.33 and 34. 0, 1, 2, 3, 4. Okay. So that's why we are going to get that value. So we'll get here this, and so again we need to write here FZZ1 plus here it is the value which is, we can try to write again. It depends upon us. Okay, you can write here 2.34 minus 2.335, or might be 2.335 minus 2.33, both are same. However, it's exactly in the middle. Because it is exactly in the middle, this value also will be exactly in the middle. So we can try to find out that 0.9904 might be the values are a little changed here. Try to write here 2.335 minus 2.33, that is more better. 2.335 minus 2.33, that is a more better value, and once you substitute that, we'll get this value over here, 0.99025, right? And having found this, then the minus of that will be 1 minus this quantity, and that's what is written over here. Okay, the first value was 0.72405, second quantity was 1 minus 99025, and we are going to get this quantity if you simplify this. Any doubts here? We can stop and discuss. Any doubts, we can stop and discuss. Please write in the chat if you have any doubts. However, for the doubts, if you have any, you can always send into the, directly to me. Okay. You want me to repeat it? Okay, I'll just go back over here. Just see this. Okay, I need to, I have to find the value at this place, 0.595. Okay, I need to find FZ at this value. This is question mark. So this is between 0.59 and 0.60, which are there in the table. Okay, what is there in the table is 0.59. This is 5. This is 59. This is 0.60. So 0.595 is between 0.59 and 0.60. 0.59 and 0.60. Okay, at 0.59 the value is 0.7224 in from the table. At 0.60 the value is 0.7257. So once we know that, I can find this by interpolation. Formula for interpolation is fzz is equal to fzz1 plus z minus z1 by z2 minus z1 multiplied by fzz2 minus fzz1. Okay, so now what is the value of fzz1? This. What is the value of z? It is this. What is the value of z1? It is this. What is the value of z2? It is this. What is the value of z1? It is this. And that's what is written over here. Right? And then what is the value of fzz2? It is this. What is the value of fzz1? Which is, it is this. Okay? And that is written over here. So after simplifying this equation, you're going to get 0.72405. In the same way, we have to find for fz minus 2.335, and that is equal to 1 minus fz 2.33. Negative values we don't have, and therefore we get 1 minus the positive quantity over here. This is equal to 1 minus the positive quantity over here, right? And this value can be again found from the table. So I have written here a mistake. Please correct this. This should be 2.335 minus 2.33. The equation written here is wrong. 2.3, the value written over here is wrong, because according to the formula over here, it is z minus z1. So z is 2.335 minus 2.33. Okay, just because this is exactly in the center, it is turning out all right, but it is not so. 2.335 minus 2.33 is what we need to write. The rest of the thing is same thing as the formula which we have written over here according to the formula. Okay, so you will get this value, and then if you try to write for this, you will get point for this. The quantities which you have found out is 72405 in the earlier slide, this one, and in the second slide we have got the quantity which is fz 2.335, but we want minus 2.335 fz value. Therefore, that should be 1 minus this, and we are going to get this. I hope it's clear now. Okay, so now let us go to the next problem. Okay, so the 10th one is there using normalized Gaussian random variable. The 10th problem is what we are trying to find out. So let us see the 10th problem in the what you call PDF. Yes, 10th is here. The random variable z is normalized Gaussian. It is given that fzc is equal to 0.5844. What is the value of c? So all these three problems are same. 8, 9, 10 are same. Okay. Out of that, we are taking only this 0.5958944. So earlier, we are given a range over here, and we are trying to find the value. Now fzc is given, and we are trying to find c, reverse. It's exactly the reverse. Okay, here what we are doing is z1, z2 we are given. We are trying to find the fz, z2 and fz, z1 and subtracting each to get this final thing. But now here what we are doing is exactly reverse. Fz, the c is given, and c we need to find, right? So let us see how we can do that. So fz, 0.5844 is what is written here. So now this 5844 should be, the value which it is given over here, and we need to find out where this exists in the table, 0.5844, where it can be. Okay. Now observe this. This is very much important. 0.5844. Where is it in the table? Inside the table. Okay. Inside the table. That's very much important. Where is my table? Yes. Okay. 5844. We need to search 5844. Now see here, 5844. Right. It is 5844 is between 5832 and 0.5871. 5844 is between these two. 5844 is between these two. So what is this corresponding to? 0.5832 corresponds to 0.21. 0.20 is this, 0.21 is this. and 0.5871 is corresponding to 0.22. This is 202122. 0.21, right? So 5832 is 0.21 for corresponding to 0.21. 5871 is corresponding to 0.22, and that's what we have taken here. See this, okay? At 0.5844 is between the values which are 0.5832 and 0.5871, and 0.5832 is at Z1 equals to 0.21 and 0.5871 is at 0.22. So what is the value of Z? It should be somewhere between these two. That's a check. It should be somewhere between these two, and how much between, we are trying to find that. How much between which we are trying to find that. So again, we try to use this similar type of formula, 0.21. Now we go in the reverse way. So C is equal to 0.21. See this over here. I want to find this. So this is equal to 0.21. Okay, plus 0.5844. 5844 is this quantity minus this quantity minus this quantity, divided by this quantity minus this quantity. Okay, 0.5844 minus 0.5832 divided by 0.5871 minus 0.5832. Okay, multiplied by the quantities which are corresponding to Z1 and Z2, Z2 and Z1, 0.22 and 0.21. Okay, so I have written the formula here. Z equal to C is equal to Z1 plus FZC minus FZZ1 divided by FZZ2 minus FZZ1. That is multiplied by Z2 minus Z1, right? FZC is this, FZZ1 is this, FZZ2 is this, FZZ1 is this, Z2 is this, Z1 is this, from the figure which I have written over here, right? Yeah, I told you how to write this figure, right? Correspondingly, we can try to find that out. Okay, so at the end, if you try to simplify this, you'll get 0.2131. Okay, this is problem number 10. Similarly, you can try to find out the solution for the problem, 8 and 9. 8 and 9 are similar. 8 and 9 are similar. So your job is, I think we have tried to solve all this. Most probably, just check it up. 5, 6, 7, all we have tried to solve, but 8, 9 are not solved. 10th is solved. Similarly, the exercise for you today is, these two. 8, 9. Please solve problem number 8, 9, and that will be a writing in the HRMS. You, even if I, don't write, then this becomes your exercise. You need to solve this and submit. Please put a notebook now itself for the assignment and try to solve whatever is told in the HRMS. Okay. So these two will become part of your assignment 8, 9. I have told you how to solve this. Similar way we need to solve this. What do you need to do? 0.6340. You need to check where it is in the table. So where is it in the table? So I'll go back to the table over here in the PPT. Okay, what was that? The value was 0.6340. 0.6340, you need to search. 6340. 6340 is somewhere between these two. 0.6331 and 0.6368. So this is your Z1 and this is your Z2. Okay. Your value of B or C, whatever we have written there, is that 6344. 6344 is the value, I think, if I'm right. Is it 6344? Is 6340. 6340 and 6340 is between these two. And what is this value about? 0.34. This is 0.35. So it should be somewhere between 0.34 and 0.35. And how much is the exact value? We can try to find out. Okay, by again the same formula. Okay, the formula is already written there, right? you need to write a similar figure like this, and you need to use this formula, and find out the value of B now. Similarly, the value of the what you call A also in problem number 8, 0.2660, 0.2660. So solve these two and put it in your assignment. Okay. So we are left with 6 minutes, right? So I'll stop it for today at this.